Our next problem is a problem involving geometry. So we're told that the perimeter of a rectangle is 44. The length is 5, less than double the width. Find the dimensions. So how do you approach something like this? We have to decide what our variable is going to be. And you might want to start by just trying things out, right? If I have a rectangle, it tells me the length is 5 times then double the width. So let's say my width is 3. You see, well, the length will be 5 times less than the double. So the length would be, the double the width is 6, and I would be subtracting 5. So it'd be actually pretty, a pretty tiny rectangle. It would have a length of 1. You see, and in that case, what would be my perimeter? It would be 3 plus 1 plus 3 plus 1, right? So it would be 8. We're quite far from 44. So probably the width is a bit bigger than 3. So if I set the width to 10, now double the width is now 20. And if I subtract 5 from that, I get 15. If I calculate the perimeter now, it's 10 plus 15, twice that, right? And that's going to be 2 times 25, so that's 50. So it's a bit too much now, you see. So of course we could adjust. It's probably the width is probably a value between 3 and 10. Okay, but let's try to do this in a systematic way by repeating essentially our process here. Essentially, we're fixing the width, right? So that could be our variable, and from that we can determine what our length is each time. So what would be our length? It's double the width minus 5. Okay, so I would start my solution like this. So let W be the width of the rectangle, then the length is 2W minus 5. Now I can translate into an equation, just like I did over here. What's given to me? I'm given that the perimeter is 44. So what's the perimeter? I have to add the width with the length. I multiply that by 2 because there's, right, width appears twice, length appears twice in the perimeter, and that should be 44. So this is now the equation I want to solve. 2W plus W minus 5 equals 44. So before solving this, what you should remember here is that it's not a bad idea to start with actual numbers, and then you try to replicate the strategy you have with numbers with variables by choosing your variable correctly. So you have to find what quantity can I vary, and as I vary this quantity, what other quantities just depend on it. So here I can vary the width, but as soon as I vary width, I know exactly what the length is. So there aren't really two variables here because I can vary width, but once I know width, I know automatically what length is, and after that I know exactly what the perimeter is. So it shows you that it's a problem that has only one variable really. So if I here group like terms inside the bracket, I get this. If I multiply out, get this. Try to solve for W. So I add 10 on both sides and divide by 6, and I get a width of 9. Okay, and then from the width I can get that the length is twice the width minus 5, so 18 minus 5, which is 13. Okay, so remember I was expecting from my initial approach a width between 3 and 10, right? 10 gave me a perimeter that's a bit too much, and 3 way too less. So I knew it was close to 10 and a bit less than 10. But let's say it would have been, I don't know, 9.51678. Okay, I would not have been able to find this by trial and error. So here it's an integer. Okay, so maybe by trial and error I would have found it. But if the dimensions are not nice, it's not something you're likely to find by trial and error. So, and at the end, we're gonna summarize our answer. So the rectangle has a width of 9 and a length of 13. That's our final answer.